All right, so we're starting chapter 6, and it looks like this. So it's got all these quadrilaterals on it. This is going to be an awesome resource for you. So use this part often. So we'll just jump right in, 6-1. So this kind of is a new language. We've been doing triangles for a while, so now we're moving on to parallelograms. So let me get started here. Need my glasses, get it all ready here. All right, so a couple things. You need to know what consecutive sides means. Consecutive sides means that they are next to each other. So next to. And two sides that are beside each other. So this side here, consecutive would be this side here. I like visuals. And this side here. So AB and DC. Next, a diagonal. A diagonal in a polygon is a segment that connects two non-consecutive vertices. So these are non-consecutive, therefore SQ is a diagonal. Formulas. I'm going to move these formulas to up here. So to find the interior angle of a polygon. So we have, put it in parentheses here, n minus 2 times 180 degrees. So the n stands for the number of sides. So n equals number of sides. So these are these interior angles, the sum of them. What are they going to equal? We know in a triangle it's 180. So in this, I don't want to do any of this. So I'm going to do this part here, which is, this is a 5-sided figure. So we're going to say 5 minus 2 times 180 degrees. And if you have your calculators out, which I do not, that's basically just 3 times 180 is 540 degrees. That is the sum of all of these together. Adding all those up. This part is almost like the opposite of. So I really want this part to belong up here to this. This is the opposite of. So to find the number of sides, use the following formula. So this is to find the number of sides. So this one is n minus 2 times the 180 divided by the number of sides. So that's a whole different formula. So formula, what do I want to do here? Here's a formula. Here's a formula. Okay? Because you'll need to refer to those. The next is to find the exterior angles. So these are all those exterior angles. And it has a formula. The sum of the exterior angles of a convex polygon, one angle at each vertex is 360. So the formula is, I feel weird because I don't know where to put it here. So 360 divided by n is what it is. So all of these angles equal 360. Okay. And that is that as well. I'm trying to make this kind of neat and concise. And I guess we could use highlighters. Exterior angle sums, maybe, and then highlight it. This is to find the number of sides. And this is to find the interior angle. I kind of like it highlighted. Makes me feel better. So those are the key things that could draw your attention. All right, let's flip on. Next page. So let's put this into practice. So we're going to find the sum of the measures of an interior angle. Okay, so that was the one where I think we just practically just did it, but we'll do it again. It's a pentagon, so you need to know your figures. It's a 5-sided figure, so your n equals 5, number of sides. And so you're just taking your n minus 2 times 180 degrees. So again, 5 minus 2 times 180 degrees, and that equals 540. Okay. This one is to find the measure of an interior angle. So that was that other formula that looked like this. Okay, so we know that equals 150. So, and the number of sides I have, we don't know, equals 150, and I'm going to put that over 1. Do you guys remember how to cross multiply? So this times this times this still works. So to simplify this, that would turn this into 150 times n, and then over here, this times 1 is just n minus 2 parentheses times 180. Now I'm going to distribute this and solve for n. So 150n is equal to 180n minus 360, 180 times a negative 2. Combine my like terms. I usually send the smallest one over, and then I'll send them, I'm going to go ahead and do that. Minus, and then I'm going to add this 360, because he's going to need to go over here. He's gone on this side, he's gone on that side, and I'm left with 360 is equal, 360 is equal to, what is that, 30n? Divide by 30, divide by 30, and then n, or the number of sides, what is 360 divided by 30? Is 12. There we go. There's that answer. Box off this answer too. Okay. Questions on that? If you want to highlight kind of how we did that here, maybe how we did that here. All right, so we are finding the measures of each interior angle. So these are interior angles, and so how much does all of this equal to? Since it's a quadrilateral, it's 4. So you could say 4 minus 2 times 180. That should give you 360. So all of these added together will give you 360. I don't know, let's see what I want to do. Do I want to say 2 times 11x plus 4, because there's 2 of those, plus 2 times 5x equals 360. You can do this however you want. This is the way I'm choosing to do it. So 22x plus 8 plus 10x equals 360. Combine my like terms, 32x plus 8 equals 360. Subtract 8, 32x equals, what is that, 352? I'm telling you, my brain is still blasé. Divided by 32. And then x, use your little calculator, is equal to 11. Now, that's only going to solve for x. It is not going to find the measures. So this is find the measures of each angle. So now we're going to take this and substitute it back in. So for r would equal 5 times 11, or 55. We know t would be the same thing. And then s, I'll do s, 11 times 11 plus 4. What is that? 121 plus 4 is 125. And there we have them. Okay. I keep wanting to ask you if you have any questions, but you're not here. All right. So a mall is designed so you have 5 walkways that meet at a food court. I love food courts. That is the shape of a regular pentagon. Find the measures of one of the interior angles of this pentagon. So you're trying to find these guys. And when it says regular, that means they're all equal. Okay. So we know the number of sides, since it's a pentagon, is 5. And so now we're just going to substitute it into this formula here to find the number of sides. Okay. Substitute our values in, or our value. So 5 minus 2 times 180 divided by 5. Punch that into your calculator and you should get 108. Finding the one of the interior angles. One of the interior angles, and that's that formula. All right, so now we're going to do the exterior angle. And this is a decagon, a deca meaning 10. And so this one is just the 360 divided by the number of sides, which is 360 divided by 10, or 36. Yay, we made it through one. All right, so now we're going to talk about parallelograms. This is just mostly vocabulary. Make sure I'm centered here. So a parallelogram is a quadrilateral with parallel opposite sides. Any side of a parallelogram may be called the base. So these denote which sides are parallel. Okay. So AB is parallel to DC, and AD is parallel to BC. So here we go with these theorems. So if you have a quadrilateral and it's a parallelogram, then their opposite sides are congruent. Opposite sides are congruent. Same thing with their angles. If a quadrilateral is a parallelogram, then their opposite angles are congruent. So you can see that. And you're going to have to note this. You're going to have to pay attention to those on your proofs and go, oh, yeah. 6.5. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay. So that means like x plus y would equal 180 degrees. This equals 360. We know that. A quadrilateral is 4 sides, so 4 minus 2 times 180 is 360. So that's why 2 of these, if these are the same, that means these 2 would be supplementary. If a parallelogram has one right angle, then it has all right angles or 4 right angles. So that means all of them would be right. Right. Okay, so this is right angles. Trying to figure out how we could do this to bring your eyes to this. So this is sides, this is angles, this is consecutive angles, this is right angles. Okay, I think I'm okay with that. Okay. Moving on. So, if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay. So AP would go with PC, and DP would be PB. Okay. If you have a quadrilateral and it's a parallelogram, then each diagonal separates the parallelogram, each diagonal, into 2 congruent or equal triangles. Okay. So ABD is congruent with DBC. Perfect. All right, so let's put this into action. So let's first of all, we have this construction. We have a parallelogram here, ABCD. B, angle B is 32 degrees. So as soon as I mark that 32, you should know D is 32, hopefully. And then you could probably figure out what C is because B and C equals 180, but I'll wait. Okay, so CD is 80, which means this side is 80. BC is 15, which means this side is 15. That's degrees. Okay, so what do I really need to find? Find AD. Oh, well that was easy. It's 15. That was almost too silly. All these things the same. Find angle C. Ooh, there we go. Find it angle C. So we know that B and C are supplementary. So 180 minus 32 is going to give me 148. Okay. So, does that work? That works. All right, let's check this one out. So if we have this as a parallelogram, find the value of R. Where on earth is R? Right there. So we know that this side and this side are equal. So 4R equals 18. Divide by 4. I could just leave it like that or simplify it or put it as 4.5. Okay, let's find S. Ooh, this is where it gets good. So what do we know about these two items, those bisectors? We know, according to up above, that let's go back up here because I do want to add this. I remember this from last year. So on our bisectors, they're saying that AP is congruent with PC. So this line here is congruent to this line here because of that bisector. So bisector, let's add this, bisector parts are congruent. Okay, hopefully that makes sense. Bisector parts of the same line. Okay, well let's keep going back down. Okay, having said that now, you should know that this side here is the same as this side. So let's just put those equal to each other. 8s is equal to 7s plus 3. S is equal to 3. That was easy. Okay. That seemed too easy. All right. Find the value of t. Where is t? Okay, so t, we have to do this angle. So this one's 40. So this whole thing is 58, which means this whole thing is 58. Okay. Since we have parallel lines, I know I'm really going to stretch here, right? This is parallel, and this is almost like your transversal. Do you see that? It's cutting through. So we should know that since this is 18, this is going to be 18. So 2t equals 18. So that's really kind of bringing us from a blast from the past. So make sure you understand, because you have parallel lines, that this could be a transversal. Okay. What else? Next, almost done, almost done. Let's go ahead. What are the coordinates of the intersection of this diagonal? Okay, so go ahead and let's plot these 4 points on this little itty bitty thing here. So, okay. So probably would do me best if I had a straight edge, but I didn't do it, but that's going to be okay. So there's my little parallelogram. It's telling me it's a parallelogram. Okay, so they want to know the intersection of my diagonals. So I'm going to do my 2 diagonals. And where does that intersect? Well, if this was bigger, we could probably see it. We may be able to see it. 1, 2. But if not, what you would do is you could do the midpoint. So to find the midpoint, so that's a blast from the past formula of NR. That was N, and this is R, or from MP. Either one. So that formula is add your x's and divide, add your y's and divide. Okay, so let's do MP. So M is here, P is here. So I'm going to add the x's. So -3 plus 5 divided by 2. And then I'm going to add my y's. 0 plus 4 divided by 2. Now make sure when you have something to solve, you solve it first before you divide. Otherwise, it's not going to work. So -3 plus 5 is 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And there you have it. We're done. All right, 2 more lessons before the break.